These equations here we'll be solving by elimination, and what this simply means is that we are going to eliminate one variable, leaving us one equation with one unknown. In these scenarios, just like with substitution, you have two equations and two unknowns. X and Y are our unknowns, but if I have two equations, I could easily solve this situation here. Now I've picked an easier one here because the variables should cancel nicely. Notice that the top one is 3x plus 2y equals a constant, and the bottom one is minus 6x. What I'm looking to do is looking for x or y that will cancel if I can add the equations together. And if they don't cancel immediately, then I can always multiply one equation times a constant to get that situation to arise. What I mean by that is, if I got a minus 6x here and I got a 3x here, the easiest way to do this would be multiply the top equation by 2, because then I'll have a 6x, right? 3x times 2 is a 6x, and that'll cancel my minus 6x squared very nicely. So multiply the whole top equation by 2, and you're going to get 6x, right? 2 times 3x is 6x. 2 times 2y is 4y. And 2 times 6 is 12. So this is a whole new equation where I've just doubled it basically. Multiplied by 2, so the whole thing doubles. Now I'm just going to rewrite the bottom equation here as is. Didn't have to multiply by anything. That's my y there. And this is a minus 6. Now I can either add or subtract them. If I want the x's to cancel, all I can do is add them. So I'm going to add this entire bottom equation to the top one and see what happens. 6x minus 6x gives me 0x. That's what I wanted. I wanted no x's left. Plus 4y minus 3y gives me a plus 1y. A 12 minus a 6 gives me a 6. Wow, that was really easy. There's no other simplification to do. So y equals 6. But I'm not done. I do have to plug y back into either equation to figure out how to get x. So let's just plug it into this bottom one here since it's right there. So minus 6x minus 3y, where y is 6, all equals negative 6. See where I get that? I'm just rewriting this equation but plugging in this 6 for the y right here. Okay, so that's a minus 6x. I'll simplify. Minus 3 times 6 is minus 18 equals a minus 6. Now I just do my algebra. Minus 6x minus 18, but I move it over, it becomes a plus 18. So 18 minus 6 is 12. And if I keep dividing by minus 6, I get 12 divided by minus 6, which is minus 2. So x equals minus 2, y equals 6. You could write this as an ordered pair, minus 2 and 6. Now that is the point where those two lines intersect. So this is the solution of this system of two equations. Okay, if I were to graph these two equations, they would intersect at x equals minus 2, y equals 6. You need to understand what that means. Okay, so let's move on here. Let's take this next system of equations, and I've got a little bit of work to do. 5 and 3, if I double the bottom equation, I'm not going to get my x's to cancel because that would give me 6x, and I need it to cancel 5x. That doesn't look like a good option. But look at the y's. I have a minus 6 here and a 2 there. What number, if I multiply times the whole top equation, would give me a 6y that would cancel with this minus 6y? Well, that number is 3. So if I multiply the whole top equation by 3, I'm going to get minus 15x, right? 3 times the minus 5x. Now the 3 times the plus 2y is going to give me a plus 6y. And 3 times minus 10 is a minus 30 over here. So I've multiplied that whole top equation. Now let's just rewrite the bottom one down here again. 3x minus 6y. Notice that nice cancellation we're going to have there, okay, equals minus 18. If I do the math now, just add these two equations. Okay, so minus 15x plus 3x is a minus 12x. Okay, plus 6y minus 6y is a plus 0y, or it goes away. Right, 0 times anything is 0. Minus 30 minus 18 is a minus 48. So now I have minus 12x equals minus 48. Divide both sides by 12. A minus divided by a minus is a plus, and 48 divided by 12 is 4. So x is 4. All right, now I have to just plug it back into either equation. Let's just pick this one here. And I'm almost out of room here. So let's plug that x into there, and I'm going to get 3 times 4 minus 6y equals minus 18. Now I just solve for y. Okay, so this is a 12 minus 6y equals minus 18. Let's just move the y over and the 18 over. 12 plus 18, right? When it comes over here, it becomes a plus 18. Move the minus 6y over, it becomes a 6y. 12 and 18, I believe, is 1, 2, 3. I believe it's 30. Okay, divided and 6y. If I divide both sides by 6, I think I'm going to get y equals 5. Okay, so up here we had, oops, up here at x equals 4, y equals 5. So our solution here is 4, 5. And just like we said with the other problem, if you were to graph these two lines, they would intersect at x equals 4, y equals 5. That's where the two lines would intersect. That is a solution to this system of equations up here, the original one we had.